4,500 years ago, without cranes, trucks, or computers, the ancient Egyptians built structures so massive that even modern engineers scratch their heads. The Great Pyramid's largest stones weigh up to 70 tons. That's like moving 40 cars by hand. But how? Was it lost technology, alien intervention, or a secret engineering brilliance we still don't fully understand? Today, we pull back the dusty curtain and reveal the shocking truth behind the pyramid's impossible construction. The Great Pyramid of Giza rises like a frozen impossibility. 481 feet tall, over 2.3 million stone blocks, some weighing as much as 70 tons. That's the equivalent of stacking fully loaded semi-trucks, without cranes, trucks, or even the benefit of the wheel. For decades, historians, engineers, and conspiracy theorists have wrestled with the same question: how did they do it? Modern construction crews, equipped with state-of-the-art machinery, would struggle with such a task. Yet these ancient builders, armed with copper chisels, rope, and manpower, pulled off one of the greatest architectural achievements in human history, and they did it over 4,500 years ago. Naturally, the mystery has fueled countless theories. Some plausible, others, well, less so. The slave labor myth still lingers, popularized by Hollywood. But archaeological evidence paints a different picture. Skilled workers, well-fed and well-organized, not slaves, but respected laborers. Then there's the alien hypothesis. Because when in doubt, blame extraterrestrials. And of course, we can't forget the wild fringe theories. Levitation devices, lost super technologies, or help from Atlantean survivors. But here's the truth. Reality doesn't need aliens to be astonishing. The actual methods are far more ingenious, revealing a level of planning, coordination, and problem-solving that speaks volumes about ancient Egyptian mastery. Moving these megaliths wasn't about brute strength. It was about manipulating nature itself. Every block was a carefully orchestrated problem-solving exercise involving physics, terrain, water, and an intimate understanding of logistics. And while we may never uncover every secret locked inside those sun-bleached stones, several fascinating theories give us a glimpse into just how these ancient engineers may have achieved the impossible. The first, a deceptively simple method hiding in plain sight, one that turns sand into their greatest ally. For centuries, researchers assumed that dragging 70-ton stones across the desert would have been an exercise in futility, like trying to pull a freight train through a sandbox. But in 2014, a simple experiment revealed something astonishing. Sometimes, the easiest solutions have been hiding in plain sight for millennia. The secret? Water. Dutch physicists studying how sand behaves noticed that when you add just the right amount of moisture to dry sand, something magical happens. The grains stick together, creating a stiff, slightly sticky surface that dramatically reduces friction. Too dry, and the sand crumbles. Too wet, and it turns into mud. But in the sweet spot, damp but not soaked, heavy objects can slide across the surface with much less effort. Their lab experiment was elegant. They placed a heavy sled on dry sand and measured the force required to pull it. Predictably, the sled dragged and dug in, creating a mound of sand that resisted movement. But when they lightly sprayed the sand with water, the sled slid far more easily. The wet sand didn't pile up in front of the sled. Instead, it stayed level, allowing for smooth motion. The resistance dropped by as much as 50%. That's not a minor improvement. It's a game changer. Now imagine ancient Egyptians applying this principle. Visualize teams of workers pouring water ahead of massive sleds, creating a perfectly damp path across the desert. The desert sun baked overhead, but the workers carefully maintained just enough moisture to keep the sand in that ideal state. With fewer men, they could move far larger stones far more efficiently. No need for magical levitation devices or extraterrestrial forklifts, just a precise understanding of nature. And this isn't mere speculation. Ancient Egyptian tomb paintings dating back to around 1900 BCE depict workers dragging large statues on sleds. In one scene, a man stands at the front, clearly pouring liquid onto the sand. For years, archaeologists dismissed it as a ceremonial gesture, but in light of modern physics, that seemingly minor detail takes on an entirely new significance. It was a practical engineering technique. The genius of this solution isn't just its simplicity, it's how it reflects the Egyptians' profound observational skills. They didn't need complex calculations or modern science. They watched how their world behaved. They understood their environment intimately, the texture of the sand, the impact of the climate, and the behavior of materials under stress. And yet, even if water-slick sand explains part of the mystery, it raises another question. What about the steeper angles of the pyramid itself? Moving stones across flat ground is one thing. But how did they lift these multi-ton monsters hundreds of feet into the air? As brilliant as the water-lubricated sand trick is, it's only the beginning. The real secrets of vertical transport? That's where things get truly mind-bending. If water-slicked sand could move the blocks across the ground, the next question is the one that's haunted engineers for centuries. How did they get those blocks up? Moving multi-ton stones horizontally is one thing, but stacking them over 400 feet into the air? That's an entirely different nightmare. The most common theory, the one many of us grew up hearing, involves ramps, enormous ramps. The idea seems simple enough. Build a massive ramp in front of the pyramid, drag the stones upward, and dismantle the ramp when you're done. Straightforward, in theory. In reality, not so much. Let's do the math. To keep the incline shallow enough for humans to pull 70-ton stones without snapping every tendon in their bodies, the ramp would need a gradual slope, let's say no more than 10 degrees. But at that angle, by the time you reach the top of the pyramid, the ramp would need to be over a mile long. And it wouldn't just be long, it would be massive, requiring more material than the pyramid itself. Think about that. Building a second mountain just to build the first one. Logistically absurd. Then there's the problem of physics. Dragging a stone up such a long ramp isn't just about weight. It's about friction, drag, and the sheer manpower required to keep those blocks moving upward for hundreds of feet. And don't forget, all of this would have to be happening while simultaneously constructing the pyramid itself. So, if a mile-long straight ramp seems unlikely, what's the alternative? Enter the zigzag ramp theory. Some researchers propose that instead of one long ramp, the Egyptians might have built switchback ramps that zigzagged up the pyramid's faces, much like a mountain road. This design would dramatically reduce the length needed while still keeping the incline manageable. It's an improvement, but it creates its own headaches. Building stable switchbacks on the smooth limestone faces would have been a feat of engineering all by itself. And as the pyramid grew taller, each new layer of switchback would have to be extended or modified in real time, constantly complicating construction. Then comes the most intriguing idea of them all, the internal ramp theory. Proposed by French architect Jean-Pierre Houdin, this theory suggests that instead of external ramps, the Egyptians may have constructed a spiral ramp inside the pyramid itself. As each layer of the pyramid rose, a gradually ascending tunnel allowed workers to pull the blocks up from within. It neatly solves many of the problems with external ramps: less material, more stability, and continuous access to every layer as construction progressed. Intriguingly, scans of the Great Pyramid using microgravimetry have revealed voids and anomalies within the structure that some believe could support this theory. If true, it would mean the Egyptians weren't just master builders. They were innovating construction techniques on a level we're only beginning to grasp. Still, even the most brilliant ramp theory only addresses how the stones were moved vertically. But how were these mammoth blocks cut, carved, and precisely fitted so tightly that not even a razor blade can slip between them? That's where we uncover an entirely different level of mastery. If the logistics of moving the stones were daunting, the precision of fitting them together is downright baffling. Some joints between the blocks are so tight that even a modern razor blade can't slip between them. The myth that the Egyptians had diamond-tipped saws or secret advanced machinery is seductive, but the truth is far more impressive. They didn't need futuristic technology. They needed patience, and a lot of it. The Egyptians primarily used copper tools, chisels, saws, and drills. Tools that, frankly, wouldn't impress a modern hardware store. But they combined these with dolerite-pounding stones, extremely hard, dense rocks that could withstand relentless hammering. Workers would pound the limestone surface repeatedly, wearing it down millimeter by millimeter. Over days, weeks, and even months, they slowly shaped each block. For granite, far harder than limestone, they employed similar techniques, but with even more time and effort. Evidence suggests they may have also used sand as an abrasive, pouring it between copper saws or tubular drills to grind through the stone with surprising efficiency. The secret to their precision wasn't speed, it was control. Rather than cut perfectly from the start, they shaped the blocks incrementally, constantly testing and adjusting the fit. Trial and error, repeated endlessly, produced joints so perfect that after 4,500 years, they still defy erosion and seismic shifts. It wasn't superhuman technology that achieved this. It was generations of refined craftsmanship, an obsessive attention to detail, and a cultural obsession with perfection. And yet, even with precise cutting and massive stones, there's still one mind-bending question. How did they align the entire structure so perfectly with astronomical true north? That's where things take an even more astonishing turn. Moving stone blocks was one thing. Feeding and managing the thousands of people who moved them? That was an entirely different masterpiece. Forget the Hollywood image of starved slaves under the whip. Just a short walk from the pyramids, archaeologists uncovered worker villages, well-planned housing, bakeries, breweries, and even a hospital. These were skilled laborers, stone cutters, haulers, tool makers, not disposable slaves, but state-supported craftsmen working on what was likely the national project of their lifetime. Estimates suggest 10,000 to 20,000 workers rotated in shifts, living on site for months. Keeping them fed meant daily shipments of cattle, fish, grain, and beer. Excavations revealed a protein-rich diet, a far cry from the meager rations one might expect for slaves. This workforce was built for strength and endurance. Tool maintenance was a full-time job. Copper chisels dulled quickly, requiring constant resharpening. Stone-pounding tools needed replacement. Supply chains stretched from distant quarries to the Giza Plateau, delivering raw materials with military-like precision. Even medicine played a role. Healed fractures and treated injuries suggest skilled medical care. The workers weren't just building a monument, they were participating in a sacred mission, believing their labor secured not only the pharaoh's immortality, but their own place in the afterlife. The brilliance wasn't just in how they moved the stones, but how they moved people. The entire operation was a feat of logistics that rivals modern mega projects. And yet, for some, this still doesn't explain everything. Because one theory flips the entire mystery upside down. What if the Egyptians didn't move most of these stones at all? For all we know about how the pyramids were built, some researchers argue that we're still missing something. That the traditional quarry haul stack model doesn't fully explain the sheer scale and precision. And so, enter the alternative theories. One of the most intriguing of them, and surprisingly plausible, is the limestone concrete hypothesis. Popularized by French materials scientist Joseph Davidovits, this theory suggests that many of the pyramid's blocks weren't carved, hauled, and stacked at all. Instead, they were poured in place. The idea goes like this. The Egyptians collected soft limestone rubble, mixed it with water, natron, a naturally occurring salt, and lime, creating a kind of synthetic limestone slurry. This wet mixture could then be poured into wooden molds directly on site, where it would harden into durable stone blocks. The result? Perfectly uniform blocks, cast layer by layer, eliminating much of the need for moving massive stones. Supporters of this theory point to microscopic differences in pyramid stones. Some blocks show air bubbles, amorphous structures, and chemical inconsistencies not typically found in quarried limestone. But critics argue that these anomalies could simply be the result of natural weathering, ancient repairs, or imperfections in the original quarries. To date, mainstream archaeology remains skeptical, citing a lack of definitive physical evidence for large-scale casting methods. Then there's the internal construction mystery. Some propose that even if the blocks were carved and hauled, we may be underestimating the Egyptians' ingenuity with internal scaffolding, hidden support structures, or innovative use of counterweights, techniques we haven't yet fully uncovered. After all, much of the pyramid's interior remains uncharted, and new technologies like microgravimetry continue to reveal mysterious voids inside the structure. Of course, no discussion of pyramid mysteries would be complete without touching on the more colorful theories. Lost ancient technologies, anti-gravity devices, sound levitation, or alien intervention. While these make for great late-night documentaries and YouTube rabbit holes, they remain firmly in the realm of pseudoscience. No credible archaeological evidence has ever suggested that the Egyptians had access to advanced technologies beyond what was available in their time. But here's the real twist. They didn't need magic. What makes the pyramids extraordinary isn't lost technology. It's that humans, with limited tools and limitless determination, were able to accomplish something so monumental using nothing more than observation, adaptation, and an obsessive pursuit of perfection. In many ways, the pyramids are more awe-inspiring because they were built by people using the tools they had, not in spite of it. And yet, beyond the stones, ramps, and theories lies perhaps the most fascinating secret of all, what the pyramids reveal about how the ancient Egyptians thought, their mindset, their culture, and their astonishing ability to turn ambition into eternity. The Great Pyramid isn't just an engineering marvel. It's a monument to the mindset of a civilization that dared to challenge eternity. For the ancient Egyptians, death wasn't an end. It was a transformation, a passage into an eternal existence governed by strict spiritual laws. At the heart of this belief was Ma'at, the concept of cosmic balance, order, and harmony. The pharaoh wasn't just a ruler. He was a living god, the human embodiment of divine order. Building the pyramid was as much a religious act as it was an architectural one. Every perfectly placed stone wasn't simply about stability. It was about aligning with the heavens. The Great Pyramid's sides are astonishingly aligned with true north, diverging by less than 1/15 of a degree. Its proportions encode advanced mathematical principles, pi, the golden ratio, even astronomical cycles. Whether by design or coincidence, the precision reflects an intense observation of the natural world and a desire to mirror the cosmos in stone. But beyond the calculations and measurements was something more powerful: purpose. The workers hauling stones under the desert sun weren't driven solely by wages or survival. Many likely believed they were securing not only the pharaoh's journey into the afterlife, but their own place in eternity. In a culture obsessed with legacy and the afterlife, contributing to the king's eternal home was the ultimate act of devotion. The scale of the project demanded not just labor, but extraordinary organization. Thousands of people worked in synchronized harmony for decades, quarrying, transporting, cutting, and stacking stone with relentless precision. They weren't building for the moment. They were building for forever. And that, perhaps, is the real legacy of the Great Pyramid. Not secret technologies, not lost knowledge, but an astonishing demonstration of what human beings are capable of when belief, purpose, and organization converge on an unimaginable scale. We marvel at the mystery because deep down it forces us to ask uncomfortable questions. What are we capable of when we pursue something with that kind of clarity? how much of what we call impossible is simply a matter of how far we're willing to go. The Great Pyramid isn't just a relic of the past. It's a timeless symbol of human ambition pushed to its absolute limit. And yet, even after 4,500 years, the sands of Giza still whisper. There may be more secrets buried beneath the surface than we've yet imagined. We've uncovered ingenious ramps, water-slicked sand, masterful stonework, and the relentless drive of a civilization obsessed with immortality. But what if the pyramid's true purpose wasn't just funerary? What if these monuments held knowledge encoded in stone? Messages meant not just for their time, but for ours. Some researchers believe there are still hidden chambers, unexplored voids sealed within the pyramid's massive core, untouched for thousands of years. Could those dark corridors hold forgotten records? Proof of techniques we've only guessed at? Or something we haven't even begun to imagine? Because the real mystery isn't just how the pyramids were built, it's why they were built with such impossible precision. As if they knew we'd still be watching, still wondering, still chasing answers. Even 4,500 years later.